All right. The topic of how to give names and formulas to ionic compounds will give us quite a short video, but there will need to be lots and lots of questions in class to practice before you're really feeling comfortable. Ionic compounds are formed when atoms of one element steal the electrons from the atoms of another element nearby. So that means that we're always going to get a positive ion and a negative ion. Because they're oppositely charged, they're going to be really attracted to each other. They will stick together, literally stick together in order to form the compound. So ionic compounds are not formed from pairs of shared electrons, but they're actually shared when a positive ion gets stuck to a negative ion. Therefore, ionic compounds must form between metals, which will want to form positive ions, and non-metals, which will want to form negative ions. Naming ionic compounds is probably the simpler part. Name the metal first. Then use another word to name the non-metal second. But it's important that you change the ending of the non-metal's name so that it will end in IDE or IDE. These compounds that I'm showing you in this video today will not ever be called ite or ate, which is the temptation for some reason. These first ionic compounds that we're learning will all end in IDE, IDE. All right, let's look at a couple of quick examples. The compound between the metal sodium and the non-metal chlorine is called sodium chloride. Notice the name chlorine has been changed to chloride. This is indicating that the element chlorine has now found itself in a compound. Zinc, which is a metal, can react with oxygen, which is a non-metal, to form a compound called zinc oxide. In this case, I had to take more of the word when I changed it, so the YGEN at the back of oxygen has been taken out and replaced by IDE to turn oxygen into oxide. Another somewhat funny example would be lithium, the metal, and nitrogen, the non-metal, reacting to form lithium nitride. Formulas of ionic compounds are trickier, but there are some rules that we can follow here too, some steps that we can just learn. First is to write the symbol of the metal, with also the number of bonds the metal will want to make above its symbol. So if we were beginning to write the formula of a compound containing sodium, we would write Na for sodium, and then up high, sort of above the line, we would write the number 1 because sodium will want to make one bond. Second step is to write the symbol of the non-metal. Again, write the number of bonds that the non-metal wants to make above its symbol. So in this case, I've chosen the non-metal, oxygen, and I've written a capital O for oxygen, and then a little 2 up high because oxygen likes to make 2 bonds. Then we swap and drop the numbers so that they will appear as subscripts. That means the little 1 will move from the sodium to under the line behind the oxygen, and the 2 will move from up top near oxygen to under the line between the Na and the O. It will look like that when it's done. So the symbol for the ionic compound sodium oxide would be Na 2O. There's a little wrinkle, which we'll practice in class tomorrow. If the subscripts happen to be the same, or if they're multiples of each other, then you can simplify them. So if you get a formula where the two numbers are both a 2, then you can simplify and make both of them a 1. If you get a formula where one of the numbers is 2 and one of the numbers is 4, then you simplify them as well. But let's save that for class tomorrow.